Yeah, they are both on the inner part. Okay, I like that. Okay, so if you had to make a guess, ladies and gentlemen, if you had to guess between angle 1 and angle 2, and given what we just saw with that little applet of things that we were moving around, what could you say about angle 1 and angle 2 if you know that B and A are parallel? Can anyone raise their hand and tell me what you might think? Yeah, Mr. Brim. They are congruent. You'd be 100% correct. And that is the corresponding angles postulate. So the measure of angle 1 is congruent to the measure of angle 2 because they are corresponding angles. Now, what's the only important thing that has to happen before you can actually assume that? Anybody see it? A and B have to be what, you guys? Parallel. Lines A and B have to be parallel, okay? Okay, that's the first box. What do you think? Not too bad, right? Okay. Now, the next one here, okay, the next box has 4 theorems in the box, okay? So there's 4 things we're going to talk about, but they go really, really fast.
You have to draw the pictures?
Yeah, just do like a quick little sketch because you can download these notes later, okay? And you can get all my pretty colors and stuff later. So just make a quick sketch, all right? So check it out. Angle 3 and 4. What do we call those angles? We call from Friday. It's also on the screen. What do you call those? Yeah, those are alternate interior angles, right? And if you know that lines A and B are parallel because those little red triangles there, okay, what can you guess? Make a guess. What do you think alternate interior angles are? Yeah, they're congruent. They're also congruent, right? So theorem 3.4 says if you've got 2 parallel lines, like I do here, A and B, and they're parallel, then the alternate interior angles must be congruent. You guys following so far?
Yes, sir.
Not too big? Not too big of a deal? All right, let's do 3.5, okay? So 3.5. So same picture, except I've chosen 2 different angles, right? I've chosen angles 5 and 6. Now, there's no way those are congruent because angle 6 is a lot smaller than angle 5, okay? So I'm going to let you copy this out and think about it, and then I'm going to call on someone to... How many people guessed what Hyro guessed?
Well, I actually knew.
Oh, you knew. Oh, okay, yeah. So 5 and 6 add to 180 degrees, right? Angle 5 plus angle 6. So theorem 3.5 says that consecutive angles are supplementary, right? They add up to 180 degrees. Now, A and B have to be parallel in order for that to be true. Okay, let's do 3.6. All right, 3.6. What types of angles are 7 and 8? This is angle 8 over here. Doesn't look very good. What type of angles are they? I wrote it down for you. Yeah. Those are alternate exterior angles. Yeah. Alternate exterior angles. So 3.6 is all about alternate exterior angles. So, same thing, right? Let's copy that down. I want you to think about what the answer might be. I've given you a hint. Measure of angle 6 and the measure of angle 8. Right there, congruent. How many people guessed what Mr. Van Dorn guessed? Yes, correct. So the measure of angle 7 is congruent to the measure of angle 8. And that's theorem 3.6. Okay, so as a review, quickly we've done theorem 3.4 says alternate interior angles are congruent. 3.5 says consecutive angles add to 180 if my lines are parallel. And theorem 3.6 says alternate exterior angles are congruent. Again, if my lines are parallel cut by transversal. Okay, last one here. Last theorem of box number 2. Theorem 3.7, right? Here's the setup. I'll read it to you. It says, if H is parallel to K, so here are my 2 lines, right? H and K. If H is parallel to K and J, line J, is perpendicular to H, then blank. See if you can fill it. Okay, so to finish this off, right? If H is parallel to K and J is perpendicular to H, then J is also perpendicular to what, everybody? K. Very good. That was the answer. Okay. 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 So right here. Perpendicular there as well. So we have 4 new theorems today, okay?
What theorem is that?
That was theorem 3.7. Okay? 4 new theorems today. Okay, for this next part, do not write this down. Don't write it down. I just want us to, I'd like us to just try this together, okay? Don't write it down. I want you to just look at the drawing and try it together. If you'd like to get the notes later, you can. Okay, so check it out. I'm going to tell you one of these angles. I'm going to tell you that this angle right here is 65 degrees. Okay? 65 degrees. I'd like you to tell me the measure of angle 6 and tell me why. Who can do it? Eugene. Taylor, what do you got? Eugene. Sorry. Sorry about that. Taylor. Sorry. Sorry, Taylor. Taylor. I was thinking of the last name. I saw it. I just saw you. I know it was totally wrong. I know it was totally wrong. All right, Taylor. Sorry about that. What if the measure of angle 5 is 65 degrees? Can you tell me the measure of angle 6 and tell me why it is that? Yes, this is 65 degrees. Now, how come? Because they are congruent. Yes, they are congruent, but what makes them congruent? What type of angles are they? Start with a V. Yeah, because they're vertical. Okay, measure of angle 7. Who can do it? Who can do the measure of angle 7? Daniel, tell me what is it, buddy? How did you get 115, dude? Yeah, angle 7 plus angle 6 is 180. What do we call that, Daniel? There's something that's called, starts with L. It's a blank pair. Yeah, nice job. It's a linear pair. Okay, number 8. Measure of angle 8. Who can do it? Rocio. Measure of angle 8. What is it? Okay, that was 65. Here, check it out. We know that 7 is 115. How about 7 and 8? What do you think, Rocio? Or 5 and 8? What do you think? See anything? No? Angle 5 and angle 8 are what types of angles, Rocio? Do you remember this from the front? What kind are they? Corresponding. What do we know about corresponding angles, Rocio? They're congruent, so let's go back to our problem here. Angle 8, what do you think? Yeah, how come? Because they're corresponding. Very good. And then the last one here. Angle 9, who can do it? Yeah, Mr. Brem, what do you got? Alternate exterior angle to which one? Which one's the alternate exterior angle? To angle 7. So can I say that? Is that all right? Yeah. All right. Awesome. So you feel like you're picking that up, everybody? Okay, last thing we're going to do together, write this down, is going to be a proof. We're going to do this one together. This is our 4th. The 3rd one was the one that we just practiced together. So this is the end of the lesson here. Now, this one is super fun. Yes, please draw it. Hey, I drew it. You can draw it. Okay. Now, I would suggest that you just sort of talk yourself through this after you look at the givens and the reasons, right? After you look at the givens, and then fill the reasons in later. Just talk yourself through it for right now. Okay. So I'll give you geniuses. Okay, here we go. Let's write that down. So what was the first thing we said as a class? Yeah, number 1, right? Number 1. P parallel to Q, given. What's number 2? Angle 1 congruent to angle 3. How come? Because they're corresponding. Okay, number 3. What'd we say? Angle 3 congruent to angle. Why? They're vertical. And then finally, number 4, what? Angle 1 congruent to angle 2 by... Dude, you guys are kicking butt. Alright, now, raise your hand if you think you could have got that on your own 100% by yourself. Yeah, you think you did? Okay. Raise your hand if you can at least follow the logic of what we've done today. Okay, so I'd say about 70% of the class. I'm going to need everybody there by the end of the week, alright? Okay, ladies and gentlemen, here is